So the primary trigonometric ratio, you're going to have to remember that word, okay, or that sentence, or these three words. Primary trigonometric ratio. They refer to sine, cosine, and tan, okay? So anytime I'm trying to solve in a right angle triangle only, anytime I'm trying to solve for a side or for an angle, I'm going to be using these primary trigonometric ratio, okay? And the measure of the angle is going to be in degrees, and the measure of the side is going to be in whatever the measure it is. It's centimeter, meter, kilometer, inches, whatever it is, okay? But primary trigonometric ratio refers to, we're going to talk about them, but it refers to sine, cosine, and tan, okay? So, how do I use primary? This is what we're trying to do right here. So I have the triangle ABC. Angle C is my right angle, right? And then, which one is my angle of interest, or angle of focus? A. A is my angle of focus, because it's the one that's given to me, correct? Remember what I said? Angle of focus is either given, or I'm looking for it, okay? So what John did here, he named the triangle, okay? So hypotenuse is the one that's right away across from the C, from the angle, 90-degree angle. Opposite is the one across from the angle of focus, and the adjacent is the one that's sharing the angle of focus. He did the same for both triangles, okay? Again, my angle of focus is X, which is the 37 degrees. Now in the table, it's asking you to, for triangle ABC, find the opposite over the hypotenuse. Like literally go and do opposite divided by hypotenuse. So for triangle ABC, what is the size of my opposite? 3, right? 3 is my opposite. Divided by the hypotenuse. What's the length of my hypotenuse? 5. So I have to do 3 over 5. What's 3 over 5?
0.6.
That's it? Exact?
Yeah.
Okay. Now I have to do the same thing for triangle XYZ, which is the one right here. So my opposite is 9, and my hypotenuse is 15. So if I do 9 over 15, what do I get?
0.6.
Good. Now, go to your calculator and look for the letters, the 3 letters S-I-N, so sine. You find them? Okay. Sine, cosine, and tan, they always come with an angle, okay? So it's either sine, whatever the angle is. So in this case, sine angle A. What's the value of angle A?
37.
So I have to do, on the calculator, you have to do for me sine 37. What do you get?
0.6018.50.
So let's leave it as 0.6.
Yeah.
And if I do sine angle X, what's angle X? 37. What's sine 37? 0.6. So what did you guys notice right here?
These triangles are the same.
Yes, number one, they are similar triangles. But what do you notice about this, and this?
The 6x, all are 6.
They're all 0.6.
0.6, okay.
Okay? Good. Now let's look for the adjacent over the hypotenuse. So in this triangle, my adjacent is 4, and my hypotenuse is 5. So 4 over 5, what do you get on the calculator?
0.8.
For the second triangle, my adjacent is 12, and my hypotenuse is 15. So what do you get when you do 12 over 15? I guess. Now the question is asking you to do cosine angle A, which is cosine 37. What do you get when you do that?
I just
0.7987
Probably to the nearest decimal?
0.8.
Should I put 37 cosine?
Probably in some calculators you have to do the angle first.
Yeah.
Did I get?
No, that's right.
Yeah? Oh,
You have to
yeah.
round it.
I've rounded first. Put
So
37
you probably
cosine.
have, no, you try cosine, cos first, cos. Equals. Yeah, cos first.
Mhm.
Okay. So you guys have you started seeing kind of trend here, something that's happening? No, not yet? Oh,
I see that these two triangles are similar. That's all I see.
Sine is the same as opposite over hypotenuse.
sine is the same as opposite over hypotenuse?
Yeah. Is it? It is sine opposite over hypotenuse.
Uh-huh. And what else did you notice?
The open.
Cosine is the same as what?
Adjacent over hypotenuse.
Mm-hmm. And what do you think tan is gonna be the same as?
Opposite over
Opposite.
adjacent.
Oh.
Yeah. Okay, let's do that. What's three? So for this triangle right here, for triangle ABC, my opposite is 3, my adjacent is 4.
What's that?
So what's 3 over 4 on the calculator?
0.78.
And for X, Y, Z, my adjacent is, sorry, my opposite is, and my adjacent is, and if I do 9 divided by 12, good.
0.75.
When we're writing this down, do we have to put the
Centimeters, no. And if I do tan 37, what do I get?
10, 37.
0.75?
Yes, I do.
Davey went down.
So, the whole idea of this is telling you that when you're doing sine of angle 37, you're actually doing the ratio. The ratio means something divided by something. You're actually finding the ratio between your opposite and your hypotenuse. Whenever you're finding sine, you're finding the ratio between opposite and hypotenuse. Whenever you're doing cosine, you're finding the ratio between your adjacent and your hypotenuse. Whenever you're doing tan, you're doing the opposite over the adjacent. No matter what the sizes of your triangle is, if your angles are the same, then your ratios are going to be the same. So, no matter what your sides are, yes? So this is 3, this is 9. This is 5, this is 15. Right? So the sizes are different. But since I have the same angle, my ratios are going to be the same. Do you guys understand that part? So we come up with this formula, or they came up with this formula. They came up that sine A is equal to the opposite over the hypotenuse every single time. And they also came up that the cosine is equal to the adjacent over the hypotenuse every single time. In a right angle triangle only. And tan is equal to the opposite over the adjacent. Okay? So they came up with this formula. Whenever I have a right triangle, I can use sine of the angle is equal to the opposite over the hypotenuse. Cosine of the angle is equal to the adjacent over the hypotenuse. And tan the angle is equal to opposite over adjacent. And that's why naming your triangle is very important. Naming which one is the opposite, which one is the adjacent, which one is the hypotenuse is very, very important. And for us to remember this, they came up with a, you probably have heard it before, SOHCAHTOA, right? And it's just an acronym to remember this. So means sine, which is equal to opposite over hypotenuse. So you have so. Okay? Sine, opposite, hypotenuse. Cosine is cap, which is adjacent over hypotenuse. Okay? And tan is psoa, which is